We'll go further in the program, and Hadewig Werbrouck of ILVO will talk about the use of FTER in dairy companies. Hadewig is a senior scientist, and she is head of the lab physical chemistry. So Hadewig, I will give the word to you now.
Thanks, Karen. Mr. Baten has already given a lot of information about the technology of the FTER and about the implementation and use of calibration curves. In this presentation, the use of FTER in the dairy industry and in the milk control labs will be discussed in more detail. The indirect alternative FTER method is routinely used in the dairy industry and in the laboratories specialized in milk analysis, such as milk control laboratories for quality and compositional analysis, such as fat, protein, dry matter, lactose, fatty acids, and ureum. Why? Compared to the reference methods, which are usually slow, difficult, expensive, and time-consuming, the FTER method is fast and easy to perform. The method also requires little or no sample preparation, and it can measure several components at the same time. It also delivers accurate quantitative results. These are the advantages of the FTER. However, this method requires daily control if you use the system daily and calibration to obtain accurate quantitative results. Which analysis do the milk control laboratories perform with the FTER? Commissioned by the government, they analyze built tank milk from the farm for fat and protein to check the quality of the milk and to determine the milk price which the buyer has to pay to the producer. On request of the producer, they also analyze individual cow's milk to manage and to improve the dairy herd. By optimizing the feed, a higher milk yield and a higher milk fat and protein content in the built tank milk can be achieved, so a higher milk price. They also use the FTER to optimize the breeding policy. This analysis is also important for the animal health monitoring. When do the dairy industry use the FTER? The laboratory technicians mainly use the FTER for the quality control of incoming and outgoing products for fat and protein. So they analyze the incoming raw milk from the farm and to analyze the produced end products. The operators mainly use the FTER during the production process, for example, to follow up the standardization of milk and cream, to follow up the evaporation process of the whey, and to analyze the cheese milk during the production of cheese. Concerning the standardization of the milk and cream, many measurements were performed during the production process of milk and cream. The raw milk, the recombining samples during the filling and after the filling. So these results has to be accurate and repeatable to achieve the levels required by legislation. The stability of the accuracy is also important to avoid temporary production stops. In the dairy industry, the accuracy is very important. So it's essential that the indirect fast alternative FTER methods provides of the same matrix with the required range of fat and protein. So skimmed milk has a separate calibration curve than full milk. Evaporated milk has another calibration curve than milk. Next to the calibration, several controls are necessary. The following controls are necessary on the device, such as maintenance, cleaning, carryover check, pump volume check, homogenizer check, zero sitting, and so on. In addition, accuracy and precision checks are also necessary for this. Control samples and proficiency samples from the respective matrix can be used. ILVO offers, together with CRAW Jean Blou, calibration samples, proficiency tests, and control samples to the Belgian Milk Control Labs and to the dairy industry. By using these samples, they are able to obtain accurate results. Concerning the calibration samples, with these samples, you can calibrate the device. As already said, this alternative method requires calibration to obtain accurate results. ILVO offers calibration samples for skimmed milk, semi-skimmed milk, and filled milk, evaporated milk, and cream for the parameters for fat, protein, and dry matter. ILVO offers also control samples. These samples can be used to monitor, to control, and to improve the quality of the analyze and their calibration curve by plotting the results in assured control cards. ILVO offers also proficiency tests, and with these samples, it's possible to determine the performance of the participating lab. The participating labs can also use the results of the proficiency test to monitor, to control, and to improve the quality of their analyses and their calibration curve by following up their performance by trend analysis. Concerning the calibration samples, as already mentioned, with these samples you can calibrate. For FTER, periodic calibration checks and adjustments with representative milk samples are necessary and crucial because it determines the quality of the results in routine analysis. The reference value must be determined by using the reference methods. This is important. The composition of the milk shows a high variability, which makes it more complicated than it is for chemical analysis of pure molecules, where they work with a dilution of per molecule. So a standard for milk was written, namely the ISO 90622. This standard describes guidelines for the application of mid-infrared spectrometry in milk and also describes the preparation of the recombined samples, which can be used for calibration. Like you see, the recombined samples covers a large range by making 9 samples. There are 3 levels for fats and 3 levels for protein, and each fat level has 3 different protein levels. This is not the case for the proficiency tests. Concerning the daily control samples, there are samples which can be used at first-line control. So with these samples, you can daily monitor and control the quality of the analysis. With these samples, also the corrections can be made by changing the intercept a little bit higher or a little bit lower. However, there is an important requirement to do this. The reference value must be determined by using the reference methods. So never change the calibration curve based on results obtained by other methods than the reference methods. Concerning the proficiency tests, there are independent checks on the quality of the analyze carried out. By participating in ring tests, participants can evaluate various aspects such as precision as well as the accuracy of their analyses. Moreover, participants gain insight into the stability of their analysis results over time by identifying trends. For example, systematic deviation can be observed within a laboratory. We organize tests for fat and protein in raw milk and fat and cream, according to the ISO 70043. After treatment of the results, 4 different assessments are possible. The first one is a high accuracy and a high precision. This means that the results of the repetitions are close to each other and that all these values, the blue dots, are also close to the reference value, the orange dot. When this is also the case for other concentrations, the slope and the intercept of the calibration is fine. The second possibility is a low accuracy and a high precision. In this situation, the repetitions are close to each other, but the results are far from the reference values. If this is also the case for other concentrations, a shift of the calibration line is observed. A third possibility is a high accuracy and a low precision. In this situation, the repetitions are not so close to each other, but the average is close to the reference value. When different concentrations were analyzed, you see a tilt in the regression, positive deviation, for example, in the low fat range, and negative deviation in the high fat range, and the mean is okay. A fourth possibility is a low accuracy and a low precision. In this case, you see a shift and a tilt of the regression. Based on the obtained results, the quality of the calibration curve can be monitored to see if the results obtained by the FTER are accurate. So, in Belgium, almost all dairy industries and milk control labs participate in the proficiency test and or use the control and the calibration samples that we offer. By using this, by following the obtained results, and by adapting the calibration curves when necessary, mostly accurate results are achieved. So this was my presentation. I don't know if there are questions, yes or no. Thank you for attention.